What's up, guys? Happy Friday. This is our last episode for the week of Quarantine Classroom. I got a new design. I decided to draw something a little different, use more space of the board. Why? Because today is all about us using what we know about circles to solve real world problems. Now, I know that you guys have been practicing and learning about the different parts of a circle and how you can use other parts of a circle um, like and use your formulas to find things that you don't know. So using what you do know and what you do know, using what you do know and what you do have to find what you're looking for each problem. Today is going to be challenging because we have to be able to, one, identify what the problem is describing in terms of what part of the circle is this problem describing, and then what we need to actually find. And so sometimes this is just not going to be always explicitly kind of laid out for us. Yep, that's what I meant to say. The warm up, you were given the diameter and it was asking you a question about the radius. So if you chose 18 for the radius, then very good. You recognize that the diameter was 36 and you needed to divide that by 2. If you did that, then you're on track to have a perfect exit ticket and to just do really well on this week's content. So without further ado, let's get straight into it. I am already logged in. I've done my warm up, and I'm at the part where we're about to like jump straight off into what the notes look like for us. And for us, that looks like one, just doing some reminders for yesterday. And then as we get into tougher real world scenarios, the first reminder that we have is that our formulas: circumference equals pi times diameter, area equals pi times radius squared. And as we are approaching these real world problems, we're having the same thinking steps each and every time. What am I looking for? What is the question asking me to find? The second thing is, what do I know? What information is already given to me? 3, does one of these two formulas have both of those things? If the answer is yes, use that one. If the answer is no, then we need to think creatively about how we can find what we're looking for by using what we have. Most times that's going to mean that we're going to have to use one formula, find the piece that we're missing, and then put that into another formula to find what we're actually looking for at the end. Once I figure out my game plan, once we figure out our game plan, we're going to substitute in the values that we know, solve for the unknown variable, and then check our work. All right. For me, that means that we're going to start with example number 1. Miss Martin is making a circular quilt and wants to include a lace pattern outside of the quilt. If the area of the quilt is 12.56 square feet, if the area of the quilt is 12.56 square feet, notice that although this is not a paper, I'm still like annotating and I'm making sure that like I pull out the information. 12.56 square feet. And I'm just gonna put it to the side. So you're gonna do this on your notebook the same way I've done it on my board. How many feet of lace does Miss Martin need to purchase? Use 3.14 for pi. So I also know that pi for this problem is going to be equal to 3.14. And what I'm looking for is something that is going to go on the outside or around the outside of the quilt. Now, it doesn't say very specifically you need to find this part of the circle. But from this definition, we know that we're going to be looking for something. I'm just going to go through my brain and I'm going to think about what could I define as being the outside or going around the outside of a circular object. I know it's not radius because radius is the distance from the center to the circumference. I know it's not a chord because the chord is distance between 2 points on the circumference. So it has to be that this is describing the circumference. It's because we're talking about going around the outside of a quilt. The total distance of the outside of a circle is known as circumference. So we know that we're looking for our circumference. Okay. So I'm going to hold off on that. We can go full screen so that you guys can just like see this is exactly what we should be doing. When I'm gonna move my computer a little bit closer so that we can like really follow along and know what's supposed to be happening here. So here I have, I know what I do have. I know what pi is, and I'm looking for the circumference. The formula for circumference, if you remember, circumference equals pi times diameter. Now, this formula doesn't have anything that we know aside from pi. So that means we're going to have to find the diameter to find the circumference. Now, what can we do to find the diameter? Well, we can use the radius to find the diameter, but I don't have the radius either. That's fine. I have the area. The formula for area, if you remember, area equals pi times radius squared. We don't have the radius, but we do have pi, and we do have the area. So I'm going to plug in the values that I do know. 12.56 is equal to 3.14 times r squared. Now, this is the same thing that we would do with any algebraic equation or any algebraic like problem. We're first going to isolate our variable by dividing by 3.14 on both sides. And when you divide by 3.14, you get, let me just double check my work. You get 4. 4 is equal to r squared. Now, because this says r squared, there is still a step that we have to do. We have to get rid of we have to get rid of our square. We have to get rid of our exponent. And the way we do that is by doing something that's called square root. Square root is basically the opposite operation for an exponent, and it looks like this. So what that looks like is, because we're still playing isolate the variable, we're still doing that by using the opposite operation. That means we have to do the square root of r squared, which ends up just being r, is equal to the square root of 4. Now, when you're asking for the square root of something, you're basically asking yourself, a number times itself equals this. What number times itself equals 4? 2, because 2 times 2 is 4, or 2 to the second power is 4. So the square root of 4 is 2. That means we have a radius of 2. How can I use a radius of 2 to find my circumference? If you're thinking about multiplying this times 2, then you're absolutely correct, because that's what we would do to put back into this equation to find our circumference. So I'm going to take this. I know that if my radius is 2, then my diameter is 4. I'm going to do 3.14 times 4. 3.14 times 4. Voila, the circumference is 12.56 feet. Now I know what you're thinking. I was thinking it too. Why is the circumference and the area the same? And the short answer is that they're not. The circumference is the distance around the outside of the circle. So the entire distance around the outside of the circle is 12.56 feet. The major difference is that when we're talking about area, it's a different unit. So this is just feet, and area is feet squared. So though we're saying the outside of the circle, the distance around the outside of the circle is 12.56 feet. The area, the amount of space that the circle takes up, is 12.56 feet squared. So that's the kind of workflow that we're looking at. We're going to look at another example. I'm going to go back to the problem. You can use this as an opportunity to pause the video and to like make sure that your notes match up with what I did on the board. And now I'm going to go on to example number 2. All right. Ms. Patel bought a new tablecloth for her dining room table that covers the table's 28.26 square feet. What is the distance in feet around the outside of the table? A couple of things that I'm going to notice is that she has a dining room table, a tablecloth that covers the table's 28.26 square feet. Couple of things. When it says square feet, I automatically know that they're talking about area. But if that wasn't it, I could see that the table, we're looking for something that covers the amount of space that the table takes up. The table takes up 28.26, but when I see square feet, I know that I'm talking about area, not circumference, not radius. As soon as you see square feet, you know that that is area because that's like 2 dimensions multiplied together. So I'm gonna go ahead and write that down first. Area equals 28.26. 28.26 feet squared. And what we're looking for is the distance in feet around the outside of the table, which we know now is us looking for circumference. We know circumference is the unknown. And something else that I'm noticing is that this problem doesn't tell me very specifically if I should use 3.14 as pi, or if I should use pi, or if I should like round up and estimate. I am going to just go with the habit of using pi because, well, using 3.14 as pi because that's what you're gonna be having to do more of than anything else. So I know that pi, again, is 3.14. So I'm gonna come out of this, and now it's time for us to work. So again, I have my area, but I'm looking for my circumference. I know that I have 2 formulas in my back pocket. Area equals pi times radius squared, and circumference equals pi times diameter. So based on what I have and what I'm looking for, is there a formula that has both of these things, what I have and what I'm looking for? No. So that means I'm gonna have to use again, algebra to make sure that so I'm gonna have to use algebra and my formulas to figure out the value of my missing variable, which in this case is circumference. Starting off, I'm gonna plug in my values for area and pi into my area formula. So instead of me being area equals pi times radius squared, it's going to be 28.26 equals 3.14 times radius squared. The name of the game is the same. Isolate the variable. I need to divide by 3.14 on both sides to get r by itself. 3.14 divided by 3.14 cancels out. That just leaves me with r squared. And now I have 28.26 divided by 3.14. 28.26 divided by 3.14, which gives me 9. This is like one of those calculations that I wouldn't be mad if you put that in your calculator, as long as you're outlining the steps that kind of shows that you know what you're doing and why you're doing it. The next step is to get rid of this exponent, which I told you guys already, which is us doing the square root function, which is the opposite of taking something to the second power. So that means I'm going to do the square root of r squared. So r squared is the same as saying r times r. So if I'm going to do the square root, I'm just getting rid of the r times r, and I'm just going to do, and so that is just r now. And then I'm going to do the square root of 9, and I'm asking myself again, what number times itself gives me 9? I know that 3 times 3 gives me 9, so I know the square root of 9 is 3. The same way that r times r gives me r squared, and I do the square root and it leaves it with r. 3 times 3 gives me 9, so the square root of 9 is 3. I know my radius is 3. I can take this radius, multiply it by 2, and I know that my diameter is 6. I'm just gonna write these full out so that you guys can like see what's happening. So my radius is 3, my diameter is 6, and I can use that to find my circumference by plugging it back into my original equation. Plugging it into my circumference equation. My circumference is equal to 3.14 times my diameter, which is 6. 3.14 times 6, which is something that we could do very easily. You know what? I'm going to do it on the board. 3.14 times 6, 24. 6 times 1 is 6, plus 2 is 8. 6 times 3 is 18. I have 2 numbers behind decimals. That means that my circumference is equal to 18.84 feet. Now, what you're gonna do every time you do one of these problems is do a formal check by taking like the value for this and dividing it by 3.14, or like you're gonna put your value that you found, you're gonna plug it back into one of these equations, and then you're gonna do the opposite operation, and it should give you. So for instance, I should be able to take 18, and here's my formal check. I should be able to take 18.84, say that it's equal to pi times 6. And if I divide by 6, I should get 3.14. And for the sake of doing this the right way, I'm actually going to show what that division looks like right here. 18.84 divided by 6. 6 goes into 18 3 times. Bring down my 8. 6 goes into 8 1 time. Bring down my 4. 6 goes into 24 4 times. That is my check. That is how I know that this makes sense. And that is how, like, this is the workflow that you're gonna do when you're doing these practice problems, level 1, level 2, your exit ticket. Your work should definitely look like this each and every time. Let me just go back to make sure that I'm not leaving anything out before I end this video. Yep. So now it's your turn to be able to like look at these problems, go through them, and make choices and decisions as to this is what I'm looking for. So the distance from one side of a merry-go-round to the other is 13.6 feet, which means the distance from one side to another is 13.6 feet. They're talking about diameter. You're going from one side of the circle to the other side, and you're going through the center to do that. So that's going to be your diameter. And they're asking, what is the distance around the merry-go-round? That means that you have to find the circumference. These are the types of questions that you guys are going to be expecting to be able to do. So if you have any questions, you know what my office hours are. You can use me. You can use my cell phone, email, FaceTime, Zoom. Definitely looking forward to seeing you all's work. Looking forward to you all being able to crush these types of questions. I know for a fact that like some of you all were able to just kind of plug and go when we had like our Warmup testing and an IA testing, but now you're gonna really be able to understand what this is. If you have any questions about exponents, I'm gonna link something in the end of your Google Forms and at the end of your classwork packet where Khan Academy and Learn Zillion explains like square root a little bit more, just in case you don't understand what it is that I just explained with that. But it's an important step that you have to know to be able to like finish doing these types of problems, especially when you're solving for radius, when it's like radius squared. Okay, hope this video was informative and helpful. Love you guys, super proud. Make sure you get all the work done and the Khan Academy. That raffle is going to be going live next week. I want to make sure that as many people from as many homerooms are getting their work done as possible, and somebody that consistently shows up. Most likely we do like the homework pass raffles. I'm going to pick one person at random and figure out something nice to do for them because you're working so hard throughout this really strange quarantine time of our lives. All right, Mr. BK signing out. Quarantine Classrooms, Season 2, Week 2, Episode 5, over, done with, bing, bang, boom. Peace.